So you guys might remember that a few weeks ago, one of my subscribers, named Chipper6, sent me a package full of a bunch of junk that his company was throwing away, and in the video I focused mostly on the HP 34970A data acquisition unit, but I kinda didn't really put much time into the servo turntable, and actually turns out it's going to be very useful for a project. Thing is though, how do we use it? Let's figure that out now. So what we have here is a custom-made turntable, but what I'm actually focusing on is the servo unit right here. This servo unit is a Lin Engineering CO4118L16501 or 16S01. And actually, as it turns out, this has a built-in controller inside of it. Now if we take this off, these are the four control pins going to the servo, and this is a standalone programmable little servo controller. It can operate between 12 and 40 volts and can work on different channels, so you can have different ones in series. Now the question is, how do we program this to run the servo? So in order to control the servo, we have to control the servo controller, or the servo driver. And this servo driver is called an R256. And Lin Engineering has a lot of information about it on their website. Now, this model of this motor controller runs on RS485. RS485 is how you put information into it, how you give it commands. It's in the same kind of standards as RS232, but it's a little bit different. It's just the input-output signals, not power or anything. So we go to pinouts and we see pin 1 is the power, so we need that. Pin 3 is RS485B, pin 4 is RS485A, so that's positive and negative of the data line. And then we'll need power ground, and we only need those 4 pins. And then I downloaded their Lin command GUI, so we can open that up. But now, the problem is though, how do we get the data from my computer into the RS485 port on the controller? Well, simple. eBay. So this is a little like $5 connector I got from eBay. It goes from USB to RS485. Now RS485 is just 2 connectors for the input-output, positive and negative. And it says on the bottom that B is negative and A is positive. So now let's wire it up. I'm going to connect this. So red is B. No, red is, okay. It's a very simple screw connector. So we'll connect this up to the USB now. So now we're going to have to finalize connecting the wires up. So I have the connector, and just find out which wires are the ones I need. Like these wires right here, this one's a sensor, so I could program it whenever it senses something moving in between this little sensor, it'll do something. Or it can send a signal out through this other wire whenever something happens. So now for this one, I believe it's red and green for the positive and negative power, and then brown and black that'll go to the RS485 connector I just installed on the back of my computer. There's the data connectors connected up. But now we need a power source, and this 12-volt battery will do. I'll just connect it up how it's supposed to be. And there we go. Now we have to program it though. Okay, so now what we're going to do is we're going to open up the motor controller GUI and try to connect with it. We're going to do it kind of just try everything, but we need to put a command in it so we know if it's actually doing anything. I'll do move absolute 1000. That'll make 1000 steps, I think. Now we try to execute, or we connect, then we execute. Nothing happens. So I change which address it's on. I think it sets at 2. And there we're going. It moved the servo thing, but unfortunately it didn't move it quite right. It kind of got stuck on something. I don't know. I think this flywheel is just a little bit too big. So let's take that off. There's a bunch of ball bearings underneath it. I'll get rid of those, because I don't want to drop them. Let's put a paperclip on here so we can see it moving now. Let's try to execute that command again. Nice! Now we can do some more stuff, like we can add a delay. Let's say 500 milliseconds. And then we add a loop block. Make it 0 so it's infinite. That up so it'll start a loop, it'll move 1200 steps, it'll delay, and then it'll repeat. So now let's clear these commands, and I want to show you something kind of odd. Like if I put in 25,000 steps and execute, it gets stuck. I don't know why. It seems it can only handle small movements, which that's fine because I'm planning on using this to rotate a telescope. So here, let's do the commands that I'm hoping to use. So I'll do, let's see how much it moves with 12. A bit too much. Let's move it 1 step. Then add another command of a delay. And finally add a loop block of infinite. And there we go. So about every 500 milliseconds, not counting like the 200 or 300 milliseconds it takes for it to execute its programming, it will move over 1 bit, as you can see it's doing right now. And this will be perfect because I can tell it exactly how fast to move. And I'm going to be using it for a very slow rotation because I'm going to be building a equatorial mount, a star tracking system, for my future telescope. That way it'll rotate at the same speed that the sky rotates. And I'll be hooking this to a gear reducer, so I'll probably be reducing it down about 100 times or so. But now the thing is, I can't have my computer always connected to it. That'd be tedious. So how do we save the program code into the servo? Okay, so let's stop that from running right now, and we can store it on the R356. I thought it was 256. Oh well. Well, anyway, store it on the device. We'll do 0, so it starts up on startup. So now those 4 lines of code have been saved into the memory of this. Whenever we reset the servo, it should start up that program. And it did, see? That'll be very useful because then I don't have to worry about turning on a computer with it. I can always just stop it, set the telescope to be where it needs to be, turn the power on, and it starts moving in the same speed as the sky. Well, I hope you found this useful and enjoyed the video. See ya!